Good evening, everyone. Welcome to day three of A.T.A.L FDP. So we have with us Professor Anamika Gupta, ma'am. So there will be two sessions today, as you know that. The topic of the session one is text analytics, and the topic of session two is application of sentiment analysis on business applications. Both of the sessions will be taken by Professor Anamika Gupta, ma'am. Now I would like to introduce ma'am. Ma'am is a professor in Shahid Sukhdev College of Business Studies, Delhi University. She is a professor of computer science and she has industry experience of 5 years in the field of network technologies and communication protocols and teaching experience of more than 2 decades in the subject areas of data structure and algorithms, computer networks, programming languages, C++, Java, Python, data analysis and visualization, data mining, machine learning, etc. Her research areas include formal concept analysis, data mining and machine learning, data analytics, image processing, natural language processing, generative AI, large language models. She has more than 40 research publications in reputed journals and conferences with publications indexed in Scopus, ESCI, and SCI having high impact factor. She is author of NCRT Class 12th Textbook of Information Practices and reviewer of Class 10th and 11th NCRT textbooks of computer science and information practices. She's editorial board member of several journals and conferences. She has been invited as session chairs in several conferences, invited as keynote speaker and resource person in several workshops held at reputed institutes like IIT Mumbai, DTU Delhi, Ashoka University, IBM Research Lab, and DRDO. She has been awarded Best Teacher Award by Government of NCT of Delhi and Nav Kiran Award in National Women Excellence Award ceremony organized by Women International Network. Now, I would like to invite ma'am to take the session.
Thank you so much, Gaurav, for inviting me. And I thank the whole team for choosing such a interesting topic, which is unlocking educator potential, essential data analytics skills and applications in business management. So I think it is need of the hour to understand the data analytics field, and we as a faculty should also be aware of all these things. Thank you so much. So I will start my presentation. Let me share my screen. Is the screen visible to everyone?
Yes, ma'am, it is visible.
Okay. So the first topic, the session one is about data analytics. And when we talk about data, the first topic is text analytics. And when we talk about text analytics, we basically talk about the unstructured data. So before text analytics, we have been always talking about data analytics. Why text analytics is different? This is something that I would like to share my thoughts on. Just a minute. I'm not able to see a few things. Just give me a minute. Is my screen coming in the presentation mode?
No, ma'am.
Okay, just a minute.
It is just showing the slides, different slides.
Okay. Is this okay now?
Yes, yes. Now it is okay.
Just a minute, please. Is it visible now?
No, no, ma'am.
Is it okay?
Yes, now it is visible.
Okay. Hmm. So, I will be discussing about text analytics, which is similar to data analytics with the difference of the keyword text. Now, when we talk about text, what is it different and why do we need different area like a text analytics? I will be discussing about that. And then I will be telling about the techniques which we can use in text analytics. So, introduction to text analytics. So, it's a process of automatically extracting insights from the unstructured text data. So, the keyword is unstructured. And we use the computational techniques like AI and NLP. So I will be talking about the NLP also, which is natural language processing, and how it is different from text mining or text analytics. And there are so many buzzwords. People call it text analytics, then text mining, NLP, and there are so many other words which are there in the literature. So I will try to explain the difference between these keywords. Why is it important? Why do we talk about text analytics? Because nowadays lot of data which is there on the internet and in real life, that is related to the text, which is the unstructured data. So that is why this new area has come up. Natural language processing. So many times you will hear this term in analogous to text analytics. It's the application of computational techniques to the analysis and synthesis of natural language and speech. Natural language like English, Hindi, other languages. So basically the techniques which are there for the analysis and synthesis of these languages. So a lot of conversation is happening in the natural language on internet, like emails, chat boxes. Nowadays we have Gen AI, which is generating the text in the natural language. So the techniques which are used to process this kind of a data comes under the head of NLP. Now, if I rephrase this, so text analytics is extracting the information and insights from text using AI and NLP techniques. What are these techniques doing? They are converting the unstructured data into the structured data so that the data scientist and analyst can use the data to process that. Now, let me explain the difference between NLP and text analytics. There is a minor difference between the two. NLP is a broader field which is focused on enabling machines to understand and process language at a deep level. These language NLP includes the things like language translation. So we can see that Google has the translation facility, and whenever we go somewhere where we are not able to understand the language, we use the Google Translator. So that task comes under NLP. So one language is converted to the other language. Then speech recognition. Again, we have examples from Google where when we speak something, then it is able to understand. Like Alexa is there. Then sentiment analysis is also one of the tasks of NLP. Then we have named entity recognition, in which we identify the entity in the given text. Then we have text generation, which we see in generative AI. So nowadays we can see a lot of applications in the form of chat GPT and all. So they all come under the NLP. Now, what is text analytics? Text analytics is more focused on extracting the specific insights or patterns from the text using the NLP techniques. So we can say that text analytics is focused more on practical applications of text data processing and may use NLP methods. But it is more concerned with the extraction of keywords or identifying the trends. So in many real world applications, we call text analytics as a subset of the NLP. So NLP is a broader area which covers a lot of tasks, and text analytics is one subset of that. In a broader sense, we can identify like that. Now we are talking about unstructured data. So what is unstructured data? From this diagram, we can see that structured data is something which we have been looking at from so many years. We have the Excel format data, we have databases, we have sales data, and we have CRM, we have other kind of data, which is there in a structured format. There have been DBMSs, Oracle and all, through which we have been able to access the information from those structured data. But from last so many years, unstructured data has come into place, like chats, notes, online communities, social media, voice transcriptions. So a lot of video lectures are there for which the transcripts are created. So they are again unstructured data. We have ratings, reviews, feedback. Then we have customer transactions. So there is so much of data which is in the form of an unstructured format. And there's a study which says that the data which is present in today's world, only 10% of that is structured and 90% of the data is unstructured. We have tools for structured data, but we don't have tools for unstructured data. And that is where text analytics come into play. And if we talk about the business applications, we can see that lot of applications belong to this unstructured data. Nowadays, without feedback, I don't think any product is going to sell in the market. Social media. For anything, we go to social media. Email. Without email, there is no communication. Chat, WhatsApp, uh, online communities. Without this, I don't think any business is working. Surveys. Right? These are all unstructured data, but they are all related to the business applications. So we have emails, customer reviews, then we have news articles. Yes, news articles are also one of the major source of unstructured data, which tells about the trends and the analysis of the market data. Then we have social media post, which tells about the brand sentiment and the public opinion. So these are the type of unstructured data which is there in the market, which is there on the internet, uh, in the real world, and we need to find the insights from that unstructured data. So I will focus more on this difference between the structured and unstructured data because we are talking about text analytics, which is dealing with the unstructured data only. So if we look at the definition, uh, I think it is more or less clear that in unstructured data, data doesn't have a structure and it cannot be easily organized. So it is very challenging. Why I'm focusing on this difference is I want to tell the challenges that text analytics is facing and why it is important to have the techniques in text analytics. So we have examples like email, social media post, audio and video files, then storage. The structured data was in the form of a database, which was normalized. We all have been working in this computer science area from last so many years. We have seen that how data is normalized and put into tables and then it is stored in the database. So a lot of pre-processing is done to make it suitable to be stored as a database. But in case of unstructured data, it is anywhere in any form. And we need to bring it to a proper format so that we can do the analysis on that. Unstructured data, we had tools like SQL and other tools through which we could analyze and we can get the insights from that. But in unstructured data, we need the advanced techniques. So we have to use NLP or the machine learning techniques to get the insights from that. Data security. It's very difficult to get the access to the data due to its unstructured nature. You know, it is difficult to get the emails, and then if we want to get the feedback, it is normally on the internet. And we have to go to some website to get the feedback from that website. So it is more difficult to get the unstructured data. There are many tools which are there for the text analytics, but we need to understand and we need to learn those tools, then only we can use them. For example, we have the programming languages, Python or R. Both are equally good, but nowadays I think more work is done in the Python. It is growing much faster than the R language. We have these spreadsheet softwares like Excel or Google Sheets, which have been there in the which have been there in the industry from a long, long time. But nowadays, Excel and Python and other tools, I think they are competing with each other. So everyone is trying to be better than the other. Then we have the visualization tools like Tableau. In the industry, you can see there are many, many tools which are used for analytics. And each company has developed the expertise in some of the tools and they are sticking to that. Then we have the NLP frameworks like NLTK, which is a library which is given for all natural language processing toolkit. Sparky is another one. Then we have machine learning frameworks like scikit-learn or TensorFlow to do the task of the text analytics. Now let me first explain a pipeline uh, through which we convert the unstructured data into the structured format, and then we do the further analysis on that. Why I'm calling this as NLP pipeline? It is a task of text analytics, but text analytics does not do anything on its own. It is all done by other techniques. So it makes use of NLP or ML or other computational techniques to get the work done. So this is one pipeline of natural language processing, which is normally done in a text analytics application. So we first collect the data. As I told in the previous slide, data collection is also a challenging task in case of text analytics because it is not freely available. It is not, there are some privacy issues and it's not there in the form of a database or in the form of an Excel. We need to extract that data from different sources. So this data collection is also one of the challenging tasks in case of text analytics. Now, once we collect the data, then it cannot be used for analysis as it is. There is a lot of processing which needs to be done so that it is suitable for the analysis purpose or the modeling purpose. So there is a text cleaning part, then there is pre-processing of the text, then text is unstructured. We need to convert that to a structured format. So we need to extract some of the features from that text. I will be explaining all these steps and the methods that we can use for that. After that, after we have converted the text from unstructured to structured format, we can use it for modeling. Modeling means that we can apply some classification tool or the clustering or other techniques of machine learning to get the insights from their data. So a machine learning lecture in the first session, it has explained a lot of algorithms which are used to get the data. So those techniques can be applied here. And of course, then we evaluate the model. And if it is not good enough, then we again go back and then we again model and then we keep on trying. See, whenever we talk about data mining or data analytics or machine learning or text analytics, we never have one solution to any problem. We keep on trying and then we get different solutions. Then we, of course, deploy that and then we monitor it. If there is a need to update the model, we update the model and so on. So this is the normal pipeline for a NLP problem. In fact, this is the same pipeline which is used for any data analytics problem. Only difference is that here the cleaning is very, very important and it involves several steps, which I am going to explain. Then pre-processing has several steps. Then extraction of features is different, right? So if I talk about image processing, again, the steps are similar with the difference that they are cleaning, pre-processing and extraction of features is different. Maybe the modeling is same. So these four steps, modeling, evaluation, deployment, or monitoring, they may be same in many of the techniques, but the data collection, cleaning, pre-processing, and feature engineering, this may be different in different problems. So when we talk about text analytics, we are talking about these steps related to the text. Now the first step, which is about data collection. So data is what? It's a text. It may be an email, a survey, a feedback, right? Or a review. So how do we collect that data? There are some API. It's not there in the, it's not easily available. We need to extract that data. So if we talk about social media, we have Twitter, Instagram, Facebook. Now there is lots of data which is there on these social media platforms. To extract that data, they have given the API. API stands for Application Programming Interface. So now this requires little bit of programming knowledge, but it's not difficult because nowadays programming is almost automated. There are code which are available on the platforms. You download that code, you generate an API, making an account on these platforms, and then using those APIs, you can extract the data. But still, little bit of knowledge is required to do this. So Twitter API, Instagram API, Facebook API, we can use to extract the social media data. Now, what is that data? This may be the comments, this may be the likes, dislikes, the network, that your friend network. So when we talk about network, there is a friend group. So one friend is friend to another one, that friend is friend to another one. So there is a network, there is a graph which is there. So that graph is used in social network analytics. So that's a specialized area which only focuses on the social networks. So different kind of data can be downloaded and different kind of analysis can be done on the data. So if I talk about, let us say the comments or the tweets, then we can talk about reviews, feedbacks, right? And we can talk about analysis of that kind of a data, which is in the form of a text. If I talk about the network, then there is a different area that is a social network analytics. Now, Twitter has stopped uh, the access of downloading of the tweets from January 23. Till December 22, they were allowing, and there were so many tweets which were there, which people were downloading and using it for the analysis purpose and for checking the sentiments or the views of the people. So now fresh data cannot be downloaded, but there are lots of websites which already have the previous data which can be used for the experimentation purposes. Of course, we need the latest tweet if we want to find out the trend, but previous data is there, latest data is not there. Insta and Facebook can be used, but Twitter was the first platform which gave the API. And because of that API, people understood the concept of extracting the data and using it for the analysis purpose. Then we have census data. So whenever there is a population census or any other kind of a census, so there is data which is available and which can be downloaded using the API. Then World Bank has given the API. Lot of people are downloading the stock market data from there, and then cryptocurrency data is also there. People are downloading those kind of things. Then the parameters which keep on changing, like gold rate or oil rate, and such kind of a data can also be downloaded from various websites. Then API usage requires programming, and those who are not expert in programming, for them, they can use the data sets which are already available on some of the websites. So Kaggle is one such source which has a repository of lots and lots of data sets. In fact, nowadays, I think everybody, whenever they start working in this area, they download the data set from Kaggle. Every single student who is working in data science or data engineering, they are downloading data from Kaggle. And Kaggle keeps on putting some challenges on the website. And students or the industry people who win that challenge, they also get recognized in the industry. So it has reached to that level. Then there are some other websites where uh, some downloaded data sets are there, like data.gov.in. Then UCI repository is there. Every student, I think, of machine learning have worked on the data set of UCI repository. UCI repository came before Kaggle, and this was, I think, one of the first repository of data sets which was there in the market and which was freely available, because getting a data set is a very, very challenging task. So UCI was the first one who gave the data sets, and a lot of scientists worked on it. So if you see the research papers um, from the time maybe 20 years before today, you will see a lot of research was comparing the results on the data sets of UCI. There were approximately 25 data sets, and people were experimenting on those data sets because they were freely available. Nowadays, there are a lot of data sets which are available on Kaggle and other websites. So UCI is not up to that mark. Then one of the very, very important method of data collection is web scraping. Web scraping means you scrape the data from the web, from the internet. So there are many websites which allow you to scrape the data, but there are many which do not allow you. So you have to take permission before doing this, or it is publicly advertised that you can use the data. Is there any question? Okay. So web scraping, I've devoted a single slide for this because I think it is very, very important that how do we collect data using web scraping. Actually, real testing of text analytics is when you scrape the data. Data which is available on the Kaggle or other websites, it is normally processed. So a lot of cleaning and the feature extraction and all those things are normally done. So you don't need to understand the complexities of the data. But when you scrape the data, then you actually understand what is the complexity of the data and what is the importance of text cleaning or text pre-processing. So it's a technique for extracting data from the websites, which involves sending HTTP request. So HTTP, I think most of us know, which is Hypertext Transfer Protocol, which is used to get the data from a website. So whenever we type some URL in the browser, we are sending a HTTP request. So it is also similar. Web scraping sends a HTTP request to a website. The website returns HTML in the response. HTML is hypertext markup language. So the content on the internet or websites, it is in the form of HTML. That HTML has all the data which is there on the website. So if the website is allowing you to scrape the data, it will process your request and send you the HTML in return. And then we can parse that HTML to get the required information. That HTML has a lot of information. So now it is up to you that what information you want to extract, you can do that. So here we can see that these are the websites. This is my web scraping software or my program in Python or in R or any other language, through which I am sending a HTTP request to the website, and website is returning me the HTML. From that HTML, I am extracting the information and then putting it into the database or Excel or JSON or CSV. So the gathered information is stored in various formats. Now, what are the tools for web scraping? There is one library. The name is Beautiful Soup, which I think most of the people who use web scraping use the Beautiful Soup package. Then Scrapy is another one. Selenium is another one. Beautiful Soup normally deals with the static data, which is not changing. But Selenium is something which is working on the dynamic web pages. So if the content keeps on changing on the website, or sometimes you see that on the website there is a button called read more. So when you are sending HTML, HTTP request to get the data, that one page is returned, but if it has read more, then the read more is not returned. So Selenium helps in that. It accesses that read more, and from that read more, it gets the more data. And that read more can be multiple times. So if you have a very big page, suppose there's a feedback of several thousand people, then it cannot be displayed on one page of the website. So when you request, you get one page, then you again request, you get another page, and so on, because it is stored in the data set in the website, but it is not shown on the website. So Selenium is more powerful in that sense that it can access the dynamic data. We have to be very particular when we are doing web scraping, because it can lead to privacy issues and it can lead to cyber security problems. It should be done only with the permission. There are websites which allow you, so you can web scrape that. Otherwise, you have to first take the permission and then only you can do that. Now, I want to talk little about JSON, because JSON is one format which is returned by the HTTP request. Nowadays, most of the websites store the data in the form of JSON. So, JSON stands for JavaScript Object Notation, and it's a format for storing the data in a text format. We used to have HTML to create the websites. Then we had JavaScript, then Java to provide a dynamic nature into that. HTML had the fixed set of tags. Of course, it has increased those number of tags, but there are limited number of tags for displaying anything on the website. So suppose you want to have the radio button, then there is a tag. If you want to have the list, then there is a tag. If you want to have a form, then there is a tag. But with the advancement on the internet and the websites, there was a need that we should be more dynamic in nature and we should be able to increase the number of properties that we want to have on that web page. Because of that, JSON was developed. So JSON can increase its size to anything. It can have sub attributes, so it can store the data in a multiple level, hierarchical level. So there's most of the websites nowadays, when we web scrape the data, it comes in the form of a JSON. It has some objects, which are a collection of key value pair, and then each of the value can be an array, which is the ordered list of values which are enclosed in the form of a brackets. This is the one example of a JSON. So here we can see that there are 4 attributes, and there is a possibility to increase the number of attributes. And each of the attribute has a different kind of a value. So this name attribute has a name, which is a string. Then age attribute is a number. A student attribute is a logical attribute, which has true or false value. Then we have the courses, which is an array form. Right? So JSON provides the ability to have more number of attributes and more number of types of attributes. That is why most of the data is in the form of JSON. So when we do web scraping, we get normally the data in the form of a JSON. And then we have to extract the data from that. So suppose it has feedback. So when I'm downloading the data using web scraping, I need to get only that field which has the feedback and maybe some other attributes which are related to that feedback. Maybe I want to know the name of that person or the age of the person and so on. Now we come to the main part of the text analytics, which is the pre-processing part. Now, when I talk about pre-processing, I am referring to cleaning, then some pre-processing. Actually, pre-processing is one part of that pipeline, but broadly we cover that into the pre-processing techniques. So it has cleaning part, then it has pre-processing part, and then it has the feature extraction part. Now, when I talk about data cleaning, of course, I am going to explain that in detail. Let me just brief about that. Whenever we download some data, suppose there is a feedback, there are some URLs which are given. Are these URLs important? Should we remove them or should we keep them? HTML tags, spell checking. So if there is a spelling mistake, then for the analysis purpose, there will be two different words, right? So we need to do that. Although these things are very, very small things, but if we don't do it, our results will not be appropriate. Then emojis, I think nowadays nobody writes a message without typing the emoji. So should we keep them? Should we remove them? Should we convert them into some emotions? So these steps we have to take care when we do the data cleaning part. Lowercase, stop words, I'm going to talk about these things. Punctuation marks, normalization, number removal. Then there are some pre-processing techniques. Tokenization, which converts the text into tokens, which may be words, sentences, or maybe characters, or maybe two words together. Stemming, which is basically bringing the word to its root level. Then lemmatization is also, there is a small difference between these two. I will be explaining that. Then feature extraction. So once we have cleaned the data, we have done the pre-processing, we need to convert that into a structured format, which is called vectorization. And there are different techniques for vectorization, like bag of words, TF-IDF, word to vec, and so on. Now, using this slide, I want to again focus on text pre-processing because it is a very, very important step of text analytics. So we have the input text. We do some pre-processing. Like these are the steps, which are normally called the very basic steps. So we can see that it is converting to lowercase so that there is no difference between the words in capital and in lower. Remove some special characters. So if emojis are there or some other special characters have been put in the text, they can be removed. Then punctuation. So punctuation normally are not useful in analysis, like commas, exclamation, and dot, question mark. These things are not important for analysis. So we may remove it. In some cases, it may be important. Okay? So it depends on the context in which we are doing the cleaning, and we have to be very particular about that. Normalize the text. Sometimes same word is written in different formats. So we need to bring that to the same format. For example, abbreviations. So abbreviations are these separate words or they should be converted into other words? How should we handle that? So that is called normalization of the text. Then we need to, after doing all these things, we need to convert the text into tokens. Now, what is a token? Is one character a token? Is one word a token? Is two words a token? Is sentence a token? Is paragraph a token? Is one page of the word is a token? So that depends again on the context, again on the problem that we are trying to solve. Normally a token is a word which is a logical sense. If we talk about English as a language, normally words are the tokens and they are separated by the blank spaces. So there are different techniques: space splitting, which is splitting the text on the basis of space, which is the word. Subspace, sometimes in the words, there are some dash written. So two words are combined by the dash. So we may be removing that. Sometimes we need character level splitting. So whatever splitting we decide based on the domain or the problem in hand, we go for the tokenization algorithm. There are many algorithms for that. There are rule-based, statistical, machine learning-based tokenization algorithm. By using any of such algorithm, we divide the text into the tokens. And then those tokens are processed by using different methods like stop word removal. Stop word is like articles like a and the. There are many. Are they important for analysis? If they are not, we should remove them. If they are, we should keep them. There are many such stop words. These are normally either the articles or the conjunctions, uh, and sometimes these are the pronouns also, which are not useful for analysis and we want to remove them. So we need to decide which stop words we are going to remove or we need to keep them. Then stemming lemmatization, which is bringing the word to its root level. And then we finally get the tokens. Once we get the tokens, we convert that into the vector format and then we do the further NLP processing, which is basically creating a machine learning model or some other NLP technique to further analyze the data. So this picture is broadly telling about the process which is used in the pre-processing part of the text analysis. Now, briefly, I will be explaining each of the technique. Removing URLs. URLs are normally not very useful for the analysis because they lead to the different page. So whenever we have a URL, we click on that, we go to the next page. So if we are doing analysis of a feedback or a review, normally the URLs are not used in the analysis. They are irrelevant and they create noise. So we need to remove them. How do we remove them? Then again, there are techniques. Nowadays, for anything that we want to do, we need not worry that how we are going to write it, how we are going to have the Python code or the R code, how the libraries are going to be used, because most of the code is available. On the Kaggle website itself, I will be showing one example also. So there are a lot of Python notebooks which are there for doing all these things. You need to mention the source of the data. You need to you need to basically shortlist that what steps you want to do. And then you can have a Python notebook for your own data. So we have the libraries like Beautiful Soup, as I explained earlier, and we have some specialized tool which can extract the content from the URL if we need to, or we can remove them. Spell checking. It's very, very important, although it's very, very simple process. Because otherwise, my model will not be able to give me the accurate results. Okay, so it brings the consistency, and there are sometimes there is a European way of writing something and there is an American way of writing something. So although it is not a spell error, but we want to bring it to the same level. We don't want that same word should be used like standardize. We write. So whether we write Z or we write in a different manner. So for analysis purpose, we can keep it same so that we don't treat them as two different words. So these kind of things we need to keep in mind when we are talking about spell checking. Again, there is a dictionary for every language which is there already there in the Python packages. which we can use to do the spell checking. So we need to just call that and do the spell check. Punctuation removal. We can see there are a lot of punctuations, colon, then arrow, then dots are there, then brackets are there, right? These are some of the punctuations which I have mentioned here. Are they useful for the analysis? Sometimes yes. Like exclamation. So if I'm talking about some expressions, so if somebody is excited about something, so they may be writing exclamation. If there are 5 exclamation written on that text, that means the person is very, very excited about it, right? So maybe in that case, it is useful. But normally we remove them because we have more useful data which is already there. So we normally do not use this punctuation. Now, when we remove that, it improves the readability of the text and the analysis becomes easier, right? Lowercasing. Now, why do we need to convert the text to lowercase? Because otherwise, the uppercase words will become different from the lowercase words. We may call it as a uppercasing also. So basically, we convert that to the same format. There are other formats also, like title format, in which the first letter is capital and the other ones are small. But instead of allowing every format, it has been standardized that convert the text into lowercase. But we have a choice. We can convert it to other formats also. So basically, the point is that the whole text should be converted to one format so that there is a consistency in the data. So capital THE and small THE, they should not be treated as different words. They should be treated as single word. And of course, it improves the accuracy if we have less number of words. Already in text mining or text analytics, the dimensions or the number of columns or the number of words that we have in a single document, that's a very, very big number. And when we increase the number of dimensions or the number of words, the algorithms become more complex. So our focus should be to decrease the number of features in any of the documents. Now, emojis, again, I don't think anyone writes a message without any emoji. Should we remove them? Should we keep them? The algorithms that we have for modeling, they do not have any provision for the emojis. Either they should be words which are again converted into the numbers. I'm going to explain that also, that how do we convert that to numbers. So emojis have no place for analysis. But are they to be ignored? Somebody is happy, somebody is sad, somebody is crying, somebody is just making fun of others, or somebody is very tired, somebody is in loving emotion. Sometimes when we are focusing on some emotions, we need to handle these emojis and we need to convert them into the words. There are tools which convert these emojis into words and then we can do the analysis. But normally we treat them as noise and we try to remove them. But it again depends on the application. We may uh, preserve the semantic meaning of that emoji by converting that to a proper emotion, and then we can do the further analysis. In fact, my second presentation, which is about sentiment analysis, people used to remove emojis from the reviews or feedbacks from where they were computing the sentiments. But now there's a specialized area which has come up, which talks about sentiments based on the emojis. So emojis are not to be ignored. As a simple step, we can remove them. But later on, if we want to have more further analysis, then we can use the emojis. Now, this was the cleaning part, which has some although very, very basic steps, but very, very important steps. In fact, lot of researchers have shown that when they don't do data cleaning, then what is the result? And when they do data cleaning, then what is the result? So by comparing the two scenarios, it has been observed that data cleaning should be taken up very, very seriously, and it improves the result to a greater level. There is a study which says that 90% of the data goes, 90% of the time of any data scientist goes in data cleaning. Because if we have the proper data, then modeling, or basically classification or clustering, and then evaluating them, then interpreting them, that's a very automated process. So our expertise basically lies in the data preparation, which includes cleaning, pre-processing, and feature extraction. If we have good data, we will have the good analysis. If our data is not correct or data is not proper, then we are not able to get the good results. So basically, most of the time goes in preparation of the data. Now, the next important part is the tokenization, which means converting text into the smaller tokens. For example, this is a very, very simple example that it says there's a sentence, we love NLP, and then exclamation mark. By tokenizing, it is converting that into words, and exclamation has also been taken as a word because it also has some importance. Again, it depends on the application, whether we want to keep the explanation or we want to remove it. And it has been, this sentence has been converted into tokens, we love NLP, and then exclamation. Okay. So tokenization means breaking down text into individual units called tokens, typically the words or the punctuation marks, like we can see here. There are other kinds of tokenizations depending on the context. There are sentence tokenizer, serve word tokenizers, and word tokenizer is the most common one. Now the next step, again a very useful step, is called normalization. We can see from this diagram that when we are writing some text, nowadays I don't think any one of us is writing the full words. We have found the short form for everything. You can see here that for writing tomorrow, people are using different methods. Nowadays, people have become very innovative in writing these short forms. Sometimes we are not able to understand also. At least I am not able to understand when people are saying new words. So before, OTW, on the way. Then using some symbols, they are defining some emotions, smile or sad or something like that. Now, what do we do with this text? So when we are talking about text analytics, we are not talking about the simple text. And nowadays people are using English. They're using a combination of Hindi and English, which has no vocabulary. How do you test that? How do you say that this word is correct or not? And when we are talking about analysis, we need to understand the meaning of that also. We are computing the sentiment. How do we find the sentiment if we don't know the meaning of that? So there are so many combinations which have come up. People are combining different languages. They are using different kind of slang. They are using abbreviations everywhere, emoticons, uh, and whatnot. I don't know. There are so many ways by which people are distorting the normal grammatical form of writing the expression. So we need to normalize those texts wherever possible. Sometimes it is not possible also. Another example is that for writing US, sometimes people write without the dots. sometimes one dot, sometimes they write USA, sometimes they write America, right? So there are different ways of expressing some words, and we need to normalize this. This particular task is a very, very difficult task because there is no standard way of doing it. You never know, some other form of tomorrow will come. So you need to upgrade that. You need to keep changing that format. You need to normalize the text, which you don't know what will come in future. So this is a very, very important and very, very difficult and challenging task. Next, stop word removal. Words like articles, conjunctions, prepositions, which have very little meaning and they are huge in number. If we look at one document of, let us say, 500 words, I think more than 100 words will be articles or the prepositions or the conjunctions. So, whenever some word is in such a frequency, it does not have any semantic meaning. Right? So, whenever we need to compute something or analyze the text, or we want to find the topic of that text, or we want to generate some kind of a text which is similar to that, we don't need these stop words. So, normally these stop words are removed, and that helps in the NLP process. Stemming. Stemming and lemmatization. These are two steps which are basically used to convert a word to its root form. Why do we need to do that? Because one word, suppose there is a word good. When we talk about different tenses, it has different names. Okay, good, better, best. So are they different words or they are same words? If we bring that to its root level, so if we have a word called best and we bring it to its root level, which is good, so all these three words will be same for us. Similarly, if a word is there, let us say walk, and there is another word called walking. Are they two different words? Or they should be treated as one word? So stemming and lemmatization brings the word to its root level. Stemming is a easier way to do it, but a very crude way. What it does is, it just removes the suffix. So if there is a word walk, there is another word called walking, it will remove ing. And then it will say walk is the root word. But same thing does not hold good for everything. For example, in good, better, best, it cannot convert best to good. Also, in some cases, removing the suffix does not make a proper English word. So, although stemming removes lot of, by removing the suffix, it converts the word into root level in most of the cases, but in some cases, it is not able to do that. So, our purpose is to bring it to the root form so that we have less number of words to handle. Stemming is an easier way. Just remove the suffix and you get the root level. But look at these examples. Crazy. It removes the suffix y, but it brings it I. It is not a proper English word. Available, it removes able and then avail is there. Entry, it removes y, then I is introduced, and so on. In some cases, it works, right? So, why do we use stemming? Because it's an easier way to find the roots. But sometimes that word loses its sense. And that is why we have lemmatization. Lemmatization also converts a word to its root form. Okay. But there is a proper grammatical way to do that. It reduces the word to its base form called lemmas. And this process is not a random process. It does not, it's not a standardized kind of a thing. It considers the context. It considers the context of the word and then convert it. So it requires a proper dictionary of that language to convert that word to its base form. And that is why this process becomes slower than stemming. But it is more foolproof method than the stemming. For example, running is converted to run. Lemmatization makes sure that both the words have the same meaning, which may not be true in stemming. Sometimes people ask, why do we use stemming if it does not bring the word to the root level? So the answer to that is stemming is much faster way to do it. It does not require any dictionary. Whenever we talk about dictionary, we may have to upgrade that. It becomes slower, right? Sometimes in data cleaning, we are not very particular about those things that we have to convert every word to the root level, right? It depends again on the application that we want to do, that how much particular we are about this process. So sometimes we want to work with only few words, which after removing the suffix, it is sufficient to use that. So we use stemming. But if we want a foolproof method, we need to use the lemmatization. It uses WordNet's built-in morphe function. There is a function in Python which is called WordNet Lemmatizer, which uses this WordNet's morphe function to check the base form of a given word. It is slower than stem. So these are the two pre-processing steps. One is tokenization and the other one is stemming and lemmatization. I consider them as same because we use either of them. So let me give you one example of a tweet. This was the tweet. It was great match played yesterday. Then there's a smiley sign. There's a comma. Thanks. You can see thanks how it is written. To all my friends. And then a full stop. So when we do cleaning of that and convert that into token. ठीक है, हमने cleaning क्या किया? We remove the emoticon. This is called emoticon. Then replace THNK to thanks. Okay, we converted to that. Remove punctuation symbols. So we remove the comma, we remove the dot, and so on. Remove stop words. What were these stop words? These are very small words like punctuation, preposition, conjunctions, or the articles. So we remove this to all. Sometimes we call some words as the small words, which are very small and which has no relevance in the context of the text. Like it was, my. So we remove those words also. And we converted this text into tokens of words. Like great is one word, match is another word, played is another word, and so on. So this is the pool of words that we got. Now there's one step which is given, which I am going to explain later on. This is called part of speech, which assigns the symbol to each of the word, which is basically whether it's a noun or a pronoun or an adjective. So this labeling has been done. They have shown stemming after this labeling because this was one of the pre-processing that they have used, but we can directly use the stemming. So here we can see that thanks has been converted to thank. So S has been removed to make it to reduce it to the base level. Then friends have been written as friend, right? Played has been written as play. So we can see that simply removing the suffix S, S, ed, it is bringing it to the root level. So many times stemming also works well. That is why we have the process of stemming also. So this is one example of a tweet which has been converted from the input tweet to a tokenizer or a vector with some words with some pre-processing which is done. There are some libraries like NLTK, which is an NLP library. This is Natural Language Toolkit. And Sparky is another library which can be used for this purpose. Now, whenever we are doing pre-processing, first we need to understand the data and we need to analyze the characteristics of the data and then only identify the challenges associated with that. That will determine the steps that I want to do on my data. So we need to understand the data. Then we need to choose the right techniques. As I have been explaining in the previous slides, then when to use which technique. And then we need to experiment. So any analytics problem is only about experimenting with different data, evaluating it, then again experimenting, then again evaluating, till the time we get a robust solution. Now I have taken one notebook, Python notebook from the Kaggle. It's not my notebook. I just Googled on the I just searched on the Kaggle and then I found one notebook. I thought it is relevant text which is given there. So I just thought I will show you that. So let me show that slide to you. Is the screen visible? Sorry, I didn't see the questions earlier. There are some questions which are given in the chat. So let me first show this, then I will take the questions. Okay. So this again, I'm telling you that this is not my Python notebook. I just searched on this Kaggle. This is the Kaggle platform from which you can download the data sets. There are many data sets which are given. I just searched here about the NLP problems having text pre-processing. There was one notebook which came. I just thought I will show you. You can download this because it is publicly available. You can use them in your programs. So you can see NLTK, which I was talking about. This is one package which is given here. Then WorldNet Lematizer, which was for the lemmatization process. Then we have the tokenizer, which converts that into tokens. We can specify, there are many options which we can specify. So I will be telling about the data pre-processing that they have done. So here you can see this text they have written for removing the punctuation. The output I can show you. They have given the output also here. This is the original text. Then after removing, they have written text without punctuation. So after removing the punctuation, you can see that this hash has been removed. You can see the next one. This dot has been removed. The next one, you can see that this apostrophe has been removed. In the next one, the comma and the hash has been removed and so on. right? So this code is sufficient to remove the punctuations. I'm not explaining the whole code. I'm just explaining the pre-processing part, which I have explained in the presentation. Then we have the tokenizer. Sometimes we use tokenizer before the stop word, sometimes we use it afterwards. This tokenizer steps, we can see here. So here we can see that this is the text, which was original text. After removing punctuation is this one. And then we can see here it has been tokenized. So we can say our deeds are, they are different tokens. So it's a word tokenizer. Now here, this the has not been removed, of has not been removed. These are the stop words. So in the next step, we will see that these stop words are also removed. So how do we call a word as a stop word? And where is the list of that? So every language has some set of stop words. So English has some stop words, Hindi has another set of stop words, German will have the another list of stop words. So in this NLTK library, we have the that list of stop words. This also we can change. So if we don't want to call some of these stop words to be removed, then we can change this. So here it has been taken into a variable that English language stop words. And these are printed, only the first 10 are printed. So I, me, I, myself, they are all called the stop words. So there are 179 stop words in this library. Now, suppose I don't want any, I want some of them not to be called as a stop word, then I can change this variable. So here we need some little bit of programming. So this variable has 179 stop words, which I can remove some of them from this, and then I can use it in the further process. So here I have written the code for removing the stop words. This is the code. So I can see here, this was my first text. Then this was without the punctuation. This was the tokenizer. And then here I can see that stop words have been removed. The, of, this, they have been removed. And now we have the uh, main core words in this text. Similarly, here I can see, right? Here also, all has been removed, to has been removed, in has been removed, and so on. Next is lemmatization or the stemming. So here it is showing that how it works. So when we call stem on a word believe, it removes the suffix e and then it gives me this word, which is not a valid English word. Similarly, believing, believed, believes, it converts that into this stem word. Then word net lemmatizer we use for lemmatization purpose. We again use this lemmatizer on the same set of words. Now it has been converted into a proper root form. So we lemmatize the whole text, and this example I can show. So this is my first text, which was converted to text without punctuation, then tokenizer, then removing the stop words. And here I can see that it has been converted to the lemmas or the root words. So deeds converted to deed, reason is same, earthquake is same, other words are same here. In the next one, I think most of the words are same. In the next one, I can see that residence has been converted to resident. So this is how lemmatization is done. Then other cleaning steps are done in this particular notebook, removing the URLs, remove the HTML tags, remove emojis, remove the numbers, and so on. And this is the text which is written for, this is the program which is written for doing that. This kind of expression that you are looking at here is called the regular expression. So by this, we define the structure of that word. So if we want to define a particular type of that word, then we can use them. For example, in URL, most of the time it starts with HTTPS. So because most of the URLs on the internet are HTTP or they are HTTPS. This caret symbol is for starting, that this word starts from this caret, and so on. So this every symbol written here has a meaning, which is called this whole thing is called the regular expression. Then this was the cleaning steps, and then we have the vectorization, which I am going to explain now in the next slides that I have. So there are methods to do that, which is basically converting the string data. So after the data cleaning, we have got something like this. This is the text that we have got. These are different words from where the data cleaning has been done. Now this set of words is ready for the analysis purpose. But this word also cannot be used directly. They need to be converted to a numeric format because most of my algorithms of machine learning, they understand the numbers. So we convert this text into numbers, which is called the vectorization process. This is the next step, which is called the vectorization process. So there are two main methods, back of words and TF IDF, which I am going to explain in my slides. Okay, then I will show this notebook also if there is a requirement, which tells about these steps. So let me just also tell you about that after doing this vectorization, we are using the classification model. So this was explained in the session 1 that how do we run the classification methods. So we convert the data into train and test, and then we have the different algorithms for classification that we use. In this particular example, they have used the random forest. After doing the random forest, they are doing the prediction. After prediction, they are using the evaluation matrices, which is in the form of a confusion matrix. This all was covered in session 1 of this FTP. And then we have different matrices on the basis of which we can evaluate the model. So I'm not going into this. I'm just telling you the full pipeline, which is given in this Python notebook. And then we try different type of classifier. This is XGBoost classifier. Then we have, I think these two only. Then we predict, and then on the basis of that, we decide which of the model we should use, which is giving the better accuracy, and then we work on that model. Is there any question till now? Let me see the chat. Somebody is asking how we can get this PPT. So this PPT has been shared with the FDP team and they will be sharing it with you. And I think there were some questions. Yeah, somebody was asking, can we use Excel to do the text analytics? See, there is a competition which is going on between Excel, Python, R, and other tools. But normally Excel deals with numbers. So they are not as good as other tools for text analytics. Mostly Python is used for text analytics. Then there is a question by Dr. Manisha who is asking, do we have demo on how to use API to extract data? Sorry, there was very little time for this session. Already we have covered almost one session, and I have few more slides to show from the first session itself. So there was not much time to show this. Maybe some other time we get to we get on the same platform, then maybe I will be able to explain that. But there are a lot of YouTube tutorials which are given, which explains how to use API to extract the data. So maybe I will share some resources related to that. So I think there is no other question. Somebody is asking, how can we prepare a research paper related to text analysis? See, if you search on net, there is whole lot of papers which are there on text analysis, but still it is growing, growing, growing. And text analytics has taken a leap in the sense that generative AI is an extension of text analytics. So text generation, which is the NLP task, this has, I think, overshadowed every other technique. Nowadays, most of the research is there in the generative AI. So all this pre-processing and all this we are talking about, generative AI tools are doing it on its own. We don't even have to write the Python code for that. So I think the next mm, area that we should focus on in text analysis should be the generative AI. So Dr. Nitesh is asking, can you explain about Twitter analysis? So Twitter has um, removed the access of its API. Now you cannot download the Twitter messages. But Twitter data is there on the Kaggle website, and a lot of people have given on GitHub also. Sorry, I forgot to mention that, but GitHub is also another very, very good rich source of data sets where people are doing research and they are putting their own data. Like one of the data that I have worked on in a project is 7 years data of cryptocurrency, and that we have put on the GitHub. We have two research papers related to that, and it was a lot of data. It took us months to download the data. So 7 years of tweets related to cryptocurrency that we have downloaded. So this, I think, um, lot of data is already there on the net. Of course, it's not latest because after December 22, they did not allow any web scraping of the tweets. But still, we can make use of it, and especially if the data is related to COVID time. So there are a lot of research which is there about before COVID, during COVID, after COVID. So that kind of analysis can be done. Thank you, Dr. Renu, that you like this session. Then Dr. Manisha is asking, can you please share a particular reliable source from which I can get detailed tutorial about API data extraction and web scraping? Okay, I will share that. I will share with the FTP team and then you can use that. Okay, so let us continue with the presentation. I'm not giving a break in between, sorry, but I think it is better to go in one flow and I will try to wind up early so that we are free for the dinner. So we were on this slide in which I was explaining about one Python notebook which is there on the Kaggle website. Again, I am repeating, it's not my notebook. I just took one example. It was already there, so I thought I will uh, give you the glimpse of the process that goes on when we do the text analysis using Python. Now, the next step is the vectorization, or it is also known as the feature extraction. So the steps are same, whether we deal with audio, we deal with image, or we deal with video, or any other format of the data. So text cleaning, the data cleaning, the pre-processing, and the feature extraction. These steps are common, but the way it is applied on our data is different. For text, it is different. For image, it is different. For audio, it is different, and so on. So I'm now talking about the feature extraction methods related to text. Again, text is challenging, we know, because it is unstructured in nature, and there are a lot of methods by which it can be converted to different formats. So this particular section, I'll be talking about that how do we find the meaningful features. Now, what is a feature? It is if I talk about one table in which there are some rows and there are some columns, then each of the column is one feature. So how do we convert the text into meaningful features so that we can use it for further analysis like classification, sentiments, information retrieval, and so on. So the first method is called bag of words. We already learned that tokenizer converts the text into words. So now we have the pool of words, which we call as the bag of words. We convert that into a structured format. It's a simple method. Each word is treated as one feature or one column. And then we define the frequency of that word as the value of that feature. So it represents text as a collection of words, but it ignores the order and the grammatical structure. So if I have a sentence that I like rain, then rain like I, or like I rain, or I like rain. These three sentences has similar representation in backwards. So there is no grammatical order, there is no syntax in the words. They are treated as independent of each other. For example, here the sentence like the cat sat on the mat. It is now a bag having the words the cat sat on mat. The is not repeated, right? Here. The will have the frequency 2. Other words will have the frequency 1. So words are also known as terms. So sometimes when we talk about text analytics, they call as a term vector. Instead of words, they call that as terms because token can be a sentence also. In that case, the sentence is the term. So term or feature or column, they are the same things. So it loses the ordering information among the words. We have the vector space representation of the text. So each of the document now is a pool of words and it is represented as a one row of that table in which the words which are present in the document are marked as 1 and the other words are marked as 0. I will show you one example. So suppose we have three sentences. So sentence is 1, I love programming. I love machine learning. Programming is fun. Let us see how it converts into bag of words. So it converts first into the vocabulary. So whatever number of documents we have, it picks all the words from that documents and makes a pool of those words, which is known as the vocabulary of that problem. So I love programming. Then I love is already there. Machine learning. Then programming is already there. Is fun. So this becomes the vocabulary of this problem. This is how that document is converted into the table format. Sentence 1, which is I love programming. I love programming. These words are given as 1. Suppose a word is repeated in a sentence. Then the frequency of that word will become 2. So basically this table is storing the frequency of the words. And the words which are not present in this sentence, they are marked as 0. Now imagine the corpus of documents. Suppose feedbacks are there. There are 1,000 feedbacks. Imagine the vocabulary that is used in those feedbacks. And one particular feedback, how many words that it has. So if there are 1,000 feedbacks, each of the feedback has at least 20 words, which means 20,000 words. if I talk about unique words, which makes the vocabulary, I'm sure it will have at least 2000 to 3000 unique words. And my feedback, one feedback, has only 20 words. So in that table, which has the unique words as the columns, which are approximately 2000 to 3000, only 20 words are present. And there may be repetition of the words. So the number of words become less. Number of unique words in that feedback becomes less. So just imagine that how many ones or how many zeros are there? Or I should say, how many zeros and non-zeros are there? Because some words may be repeated. So number of zeros in this table will be much, much more than the number of non-zeros. When the number of zeros are more, that data is known as a sparse data. And sparse data has its own complexity because it becomes huge. Table becomes huge. And my algorithms of machine learning, they become complex when the number of columns are more. They are okay with number of rows. You can increase the number of documents. But if the number of columns increases, then the complexity of the algorithm increases. It increases with number of rows also, but it is more impacted by the number of columns. So when the number of columns increases, then it becomes difficult to run the algorithms. So this particular table, you can imagine, this is a sparse data. So most of the fields in this data are zero, with only few of the field as the non-zero. Another important thing here is, for a given sentence or for a given feedback or review or survey, I'm more bothered about the words which are present. I'm not bothered about the words which are absent, which are more in number, right? So suppose I go to the market to buy something, I'm more interested in the products that I have bought. I'm not interested in the products that I have not bought, right? So this is like that only. So my feedback, I'm uh, it is more important to know the words which are present in that feedback than the words which are not present. So this kind of attributes or the features or the columns in which number of ones are less than, number of non-zeros are less than the zeros, and zero has little significance. Non-zero has more significance. These kind of attributes are known as asymmetric attributes. So these are the vectors. These are called vectors. They are based on the word frequency. This data is sparse and the attributes are asymmetric in nature. I hope I have made it clear. Is there any question? So now when I convert the documents, which I call as a sentence, so one sentence is one document for me. So when I convert my documents into this vector format, into this table format, what do I want to do next? Suppose I want to know that which documents are similar to each other, which is an NLP task of finding the similar documents. For example, when I do Google search, I want to find out the documents which are related to that search query. So I want to know which documents are similar. Right? So I want to know whether sentence 1 is similar to sentence 2 or sentence 3. They are not exactly same. Right? These sentences are not same. What we can do is we can find out which are more similar to each other. There will never be two documents which are same. They can be similar in nature. That they have some features or some words which are common and some words which are not common. So now I am interested in finding out whether my documents are similar or not. This is one of the text analytics technique which is used to find the similarity of the documents, which again is used in many of the NLP tasks. So there are two main methods which are used. One is called the Jacquard similarity. So it is a measure of similarity between two asymmetry, which I explained just now, where the number of zeros are more than the number of non-zeros, and zero has little importance. So two asymmetric binary vectors. Binary means it can have only 0 or 1, or two sets or two text documents. So the value of Jacquard is from 0 to 1. This I will explain with the example also. So the computation of this is that number of observations in both the sets. So if we have two documents, so number of observations in the both set which are 1 divided by number in either of the set. So this is the formula. So if I'm trying to find out between the set A and B, which I'm, let us say, my two documents, intersection of these two documents divided by the union of that. Intersection means that's words which are same in both the documents. And union means all the words. So it is the whole vocabulary. Okay, so let me take one example. Let us say these are the two documents which have certain words which have been tokenized and pre-processed, and we are getting these two vectors as the documents. Now, number of observations in both, that means in both, the words which are same. So, lion is same, cheetah is same. I'm not showing that tabular format. This, I think you can understand here. So, this has number of observations which are same is 2. Now, how many observations are there? Now, here, because it is asymmetric, it is only considering the words which are present in either A or B. Had there been set C also? Because when we talk about the bag of word, it has the vocabulary which is there in all the documents. So if we want to compute the similarity of two documents, we are not considering the words which are not present in those documents. Right? We are not taking the whole vocabulary. We are only taking the vocabulary which is here because it is asymmetric in nature. So zeros are not important for me. The words which are not present in A or B are not important for me. So I am taking only the words which are present in A or B. So this becomes 8 words. Now suppose I take all of them. I take the whole vocabulary. Let us say I have a similarity measure which takes all the vocabulary. Because normally this is how we do. That number of matches divided by total number of possibilities. The total number of possibilities, just imagine. We took one example, small example, that it may have 2000 or 3000 unique words, out of which these documents has only 5 words. Now, if I take that 2000 as the total number of words, the similarity between these two documents will come out to be 2 upon 2000. That means these two are not similar. Even if these 5 words are same, the similarity will come out to be 5 upon 1000, 2000. That means these two are not same. Okay? But we can see that if 5 words are same in both the sentences or both the documents, then they are same. That is why this formula, Jacquard similarity, uh, uh, has been built based on the fact that the attributes are asymmetric in nature. Now, if 5 words are same in both, then the similarity measure will be computed as 5 upon 5, which is 1. That means they are both same. In this particular example, it is 2 upon 8, which is 0.25. So they are not very similar to each other. They have something in common, but they are not very similar to each other. Okay. So this is called Jacquard similarity. Similarly, we have another metric which is called distance, which is opposite of the similarity. So it becomes 1 minus the similarity. So it becomes 0.7. Now there is another metric which is for computing the similarity. Why we are talking about these matrices? Because similarity of the documents is required in many text analytics techniques. Now, cosine similarity is mathematically the angle between the two documents. I'm not going into detail of that. Let me just give you one example of this. The formula is that it takes the dot products of the vector. So if both the words have 1, 1, then this will become 1. And if one of them is 0, that means it is not present. This product will become 0. Then square root of all the ones in the first document, square root of all the ones in the second document. Okay, let me show one example. So these are the two documents for which we want to find the cosine similarity. This is the table, this vector which has been created using the bag of words. So here we can see that the is repeated. So it has vocabulary 2, frequency 2, and then all the words have 1. Add and intruder are 0. Similarly, for the second sentence, this has been created. For the cosine similarity, it computes the dot product. That means it computes the product of these, these, and so on. So it comes out to be 4 plus 1 plus 1 divided by square root of square of these, and then multiplied by square of these, which is around root of 80. So this is another way to compute the similarity of the documents. So now we can appreciate that why we were doing the pre-processing and then cleaning of the text. Suppose these two other documents, so we do all the cleaning so that the words which are very, very common are removed, which are not useful for the analysis, they are removed, so that this table becomes a reasonable size table and it has more useful information than the other information. Now there are some issues in bag of words. It's a very, very simple technique. So the first step that we do is we convert that into bag of words, but it loses the context or the semantics. Now, if we talk about generative AI, I think everything is based on the context. So they have taken the text analytics to the next level by using the context of the words. It generates the word based on the previous words. So the whole thing is taken into consideration. So bag of word doesn't fall into that category. Data is very, very sparse. So it becomes huge and it becomes unmanageable. To resolve these issues, we need to have some method which can remove the sparsity of the data in that bag of word, plus the frequencies. We need to normalize the frequency associated with the individual words so that we don't lose the context. Although it is very difficult to have the techniques which holds the whole context, but something can be done in that area, and that technique which is taking care of little of context is the TF-IDF. Now, before taking it to TF-IDF, which is the term frequency, inverse document frequency, let me first tell about what is normalization or what is inverse document frequency. This will be taken care of in the next technique, which is used for vectorization of the text. Now, inverse document frequency. When we talk about frequency of a word in a document, we call that as a term frequency, TF. So in the previous example, in bag of words, we are taking care of the term frequency. So the words which are more common in their document, they are considered. But what if that document is present in all the documents? That word is present in all the documents. Is that relevant? So if there is some word which is very, very common among all the documents, that means it loses its significance. So it is not just important to know the frequency of that term in the document. It is also important to know whether that word is present in other documents or. So that is called the inverse document frequency. So if there are higher frequency words, normally those are words like the, some, and those kind of words which are high frequency words, always they will uh, obstruct in the process of similarity computation. We saw the formula for Jaccard similarity, for the cosine similarity, where the higher frequency words have more importance. But if there are higher frequency words which are higher in frequency in every of the document, in the whole corpus of documents, that means it loses its significance and we need to remove them to compute the similarity or any other computation related to the text or the documents. So here we are dealing with that kind of a problem where we want to remove the most commonly occurring words. That means we want to have some words which are rare in that document along with the presence of that word is more frequent. So we are looking at both the things. In a particular document, the word should be more frequent, which is called the term frequency, but that word should be a rare word corresponding to other documents. So if that word is present in other documents also, then it loses its significance. So we are computing TF and we are computing IDF, which is inverse document frequency. And then we take the multiple of both the things to compute whether that word will be significant for the further processing or not. So if two documents match on an uncommon word, it is more indicative of similarity. Here, it is very important to understand this, that it is saying if two documents match on an uncommon word. If it is matching on the common word, then there is nothing to understand or there is nothing to nothing to find the similarity. So we need to find out whether the word is uncommon or not. Removal of stop words is motivated by this aspect. Stop words are the words which are very, very common. And if we don't remove them, they will be they will impact the similarity computation. So we can see that Jaccard similarity or cosine similarity, if something has a higher frequency, they are given more weightage. So that is why we need to remove those stop words which are more frequent in nature. So what is inverse document frequency doing? It is removing the words or giving less weight to the words which has higher frequency. Term frequency is giving more weight to the higher frequency words in the same document. And IDF is giving less weight to the words with higher frequency in corpus of documents. Okay, so term frequency is working on one document. IDF is working on the corpus of document, which is the whole set of documents. This is the formula for finding the inverse document frequency. Formula for term frequency is very, very clear, that it is the number of times it is occurring in the document divided by the total number of words in the document. And IDF is log of n upon ni. N is the total number of documents. Ni is the number of documents having that word. So suppose there are 3 documents and all of them have the same word. Then this will become 3 upon 3, which is 1. Log of 1 is 0. That means if there is a word which is common in all the documents, then it loses its significance. Its IDF is 0. If suppose n is fixed, which is 3, ni is 1, then this is log 3. Ni is 2, then this is log 1.5. So it decreases in the reverse order. Let me take some more example related to that. Based on this IDF formula, then there is another technique which is there for vectorization, which is called TF-IDF. So it takes term frequency and inverse document frequency. And it's a score to highlight each word's relevance in the entire document. So let us take an example of these 5 documents, which are all related to topic model. Now, each of the document here you can see has a word topic, 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 topic. Now, do you understand why we lowercase the words? Because this topic and this topic should be treated as same. So each of the document has the word topic. That means if I want to compute the similarity of 1 and 2, I should not consider topic as a word. Because वो तो है ही है. It is present in all the documents. So there is no significance of finding the similarity based on this. So it removes that. Right? And then we can find the similarity based on other words. This is the purpose of IDF. So let us take some more example. Let us say this is one example of documents related to cricket. There are 3 documents. And each of the document has certain words. So let us pre-process that. Cricket is removed. Popular, sport, India. Okay, there are 4 words. Now, what is the term frequency of cricket here? It is 1 upon 4. There are 4 words. So the term frequency, the TF, is 1 upon 4. So term frequency is related to one document. But when I talk about IDF, it is related to all the documents. So for the word cricket, if I want to find the IDF, that means the inverse document frequency of cricket word. Then cricket is present in 1, 2, and 3. So by the formula, it becomes log 3 by 3, which is 1. Log 1 is 0. That means cricket has no significance related to the similarity of these documents. Right? Because it is present in all the documents. So it's a very common word and it loses its significance. So the purpose of IDF is to find out the rare words among the documents. And TF is to find out the common words within the same document. Right? So combination of this is used to find out the significance of words. So let us compute the TF for all the documents. Now here also you will have an interesting observation. This is the whole vocabulary, the words taken from these documents. TF of document 1, it has 4 words. Cricket is 1 upon 4, popular is 1 upon 4, sport is 1 upon 4, India is 1 upon 4. So it is the frequency of that word divided by the total number of words in the document. Now here popular is occurring only once and its significance or the TF is 0.25. In the next document, player is also occurring once. Now look at the TF of this player. It is 1 upon 6 because there are 6 number of words in the document. So what is it signifying? Term frequency of player is less than the term frequency of popular. That means popular has more significance in document 1 than the word player in document 2. See, so frequency is same, but it depends on the number of words in the document, which is defining that how the term frequency is telling the significance of that word in the document. So player has little role in that document. So if I have to weigh something, then player will have less weightage. Similarly, for the document 3, it has certain weightage. Fan word has weightage 1.5 because there are 5 words. So if there are more number of words in the document, each of the word has less significance than the other words. So this is the TF calculation. Now let us look at the IDF calculation. This was the formula. Now here we look at all the documents. In the previous case, we were looking at each document separately. They were independent. Right? TF of this, TF of this, and then TF of this, they were independent. In IDF, all the 3 documents are used to compute the inverse document frequency. So it is computing the significance of a word related to the corpus of the documents or related to the whole data set of the documents. So now the cricket word. How many documents it has? This DFT is how many documents has this word. Then formula is N is 3 and the number of occurrences of that document, of that word, which is 3. Here it is 0. Popular, it is in one document only. So it is 3 upon 1, which is 1.0986. Now popular and the word player, they have the same idea. In TF, they were different. But here it is same because the formula says N upon number of documents it is having. It is not talking about the total number of words in the document. Right? So this formula and the player formula, they are same. So IDF of both the words is same because they are occurring only once in a document. They are occurring only in one document. Now next is we compute the TF into IDF for each of the document and each of the word. So I will look at this column, which is computing the TF into IDF. TF is telling the frequency in the same document and IDF is telling the significance of that word among the set of the documents. So here we can see cricket is 0. That means we don't have to look at cricket word if we are looking at the significance of the words. Popular, it is multiple of these two, then sport, and then India. Right? So we can see there is a combination of TF, IDF. Similarly, in document 2, there is a combination here. And similarly, document 3, there is a combination. So there are different values which each of the word has obtained and each of the document has obtained. If we look at the word, we can see that for each of the document, it has a different significance. Right? So this TF IDF is used, it has some context. Right? It is reducing the impact of common words and highlighting the important words in a document. So the common words थे among the set of documents, both significance is 0 or less as compared to the words which are uncommon. So I'm just repeating what I have told. TF IDF is a metric which combines term frequency and IDF across the collection of documents to determine how important a document word is to a document. Low TF IDF score means word is less important but less relevant to the document. High means word is both frequent in the document and rare across the collection of documents. Okay, so it is checking both the things. Frequency in the same document and rarity among the collection of documents. Okay, I think I have told enough about this. I will just skip this. So this was about the term vector IDF, which is a very, very important technique for vectorization of the documents. Another important technique which is used in vectorization is part of speech tagging. Now, part of speech converts each of the word into its grammatical structure. So whether it is a noun, it's an adjective, determiner, or a preposition, and so on. This is also used in lot of research areas where we are dealing with the fake reviews or fake comments, where we can find out from by putting it into the grammatical structure. Suppose there are a lot of adjectives in a given feedback. It looks like a fake feedback because normally we don't tend to write so many adjectives. Suppose it has contrasting adjectives. That means it has been generated by something. Right? So based on the grammatical structure, some information can be gathered related to that document. So it analyzes the grammar by dividing the sentence into the different labels like noun, verb, adjective, and so on. Suppose this is the sentence which we need to convert into POS. These are the tokens. the quick, brown, fox, and so on. When we talk about POS, it converts that into DT stands for determiner, JJ for adjective, JJ adjective, NN for noun, verb, then determiners, preposition, sorry. This is preposition, then a determiner, adjective, noun, and so on. So this documents are converted using POS. So this becomes the POS, and we have these numbers. Based on that, also several analysis can be done. So there has been research which I have seen. There are some notebooks on the Kaggle website which deals with POS and then categorizes a review as a fake review or not. Then there is another technique to vectorize the document, which is known as a n-gram models. So it does not deal each of the word as separate. It deals with the sequence of words. When we deal with sequence of words, we carry the semantic meaning. So if we deal with 2 words or 3 words or 5 words or 10 words, then there is a grammar and there is a meaning associated with that n-gram. So if there are 2 words, suppose there's a word called not and not happy. If we separate them into 2 words, not is a separate word, happy is another word. Then they loses the significance of it. But if we combine them, then it has a different meaning. When we take 2 words, it is called 2 gram, or it is also known as bigram. Suppose we take 3 words, then it is known as trigram, and so on. So, a lot of research has been done by converting the words into n-grams. So, they say instead of taking each word as a separate entity or a separate token, let us take combination of them and then we call them as n-gram. Vectorization process is same. Only thing is that 2 words are taken as uh, um, one feature or one column. For example, this is the sentence, natural language processing is fun. If I talk about unigram, which is the process which we were following earlier, so each of the word is 1 gram. So natural language, they are different words. If I talk about bigrams, which is 2 words at a time, natural language is one feature. Then language processing is another feature. Processing is another feature. Is fun is another feature. If I talk about trigrams, the natural language processing is one feature. Language processing is another feature. Processing is fun is another feature. So this reduces the number of columns also because we have taken a combination of words. Till now, we have been talking about the techniques which are related to cleaning, processing, and then feature extraction. So in feature extraction, we talked about bag of words, then we talked about PFIDF, then POS, then we talked about n-grams. I have not gone into much detail of that, but I have given you some brief about that. Rest of the things are almost automated. Once we have the set of features in a vector format or in a tabular format, we apply the machine learning algorithms and then we evaluate them, which I have shown you using the notebook also. So we have the model building in which we apply the algorithms for classification or clustering, and then we evaluate them on the basis of certain matrices like precision, recall, accuracy, and so on. So this is about text analytics, that how do we convert a text which is an unstructured format to a structured format. Text analytics is evolving. It's growing and growing and growing. There is no stopping of that. By the generative AI, it has grown to a bigger height. And why it is growing? Because unstructured data is growing. Nowadays, we can see that structured data is very, very less, and most of the data is the unstructured data. So it will keep on growing. So those who want to do research in this area, I think it's a good idea to start working in this area, which will always give you some challenges which you can use in your research. So this was my first presentation. This has been extended, but second presentation is smaller. I can promise that because I knew that this portion will take some time, and then only we can understand the next portion. So I will move on to the next presentation. Trying to figure out where is that. I can't see the whole screen. Let me join the meeting again. I am not able to see the screen.
Ma'am, you have shared the screen, the future of text analytics.
Yeah, but I am not able to see that on my screen.
Just wait a second.
Yeah,
Now,
yeah, yeah. Now I can see.
share the screen again.
Right. So I will show the next presentation. Sorry for this all confusion.
No problem, ma'am. Yes, it is visible, ma'am. Application of sentiment
Okay.
analysis in
Okay.
business and ma'am.
Okay. Okay. Thank you. So this is my second session presentation, but I knew that I need to build the basics. Then only I can explain about this. Now, before going into the application of sentiment analysis in business environment, I will be talking about some of the NLP techniques. Sentiment analysis is one of those techniques. So just to give a broad idea about the umbrella under which this applications are there, let me just quickly go through what are the NLP or the text mining applications. Now, I've introduced a new term, text mining. It's same as text analytics, similar to data analytics versus data mining. So when we talk about data analytics, we talk about the analysis techniques related to data, and then mining is a process of getting the insights from that using certain techniques like classification, classification, clustering, and association rule mining. Similar to that is text mining. So, as a common term, we can say text analytics or text mining are similar. So, sentiment analysis is one of the technique majorly used in nowadays in a lot of applications and in research. So, sentiment analysis, I think most of us know that it determines the emotional tone expressed in the text, mostly identifying it as positive, negative, or neutral. So, there are three emotions which are given, whether the feedback or the survey is positive, negative, or neutral. But nowadays, people are talking about more emotions also, which I will be talking about in the next slide. It's very, very useful for the customer feedback to find out the trends in the social media, market research, then monitoring of the brand, product review analysis, social media sentiment tracking, and whatnot. I think everything is nowadays is sentiment related. So we need to do the sentiment analysis to understand the opinions. We have various applications in this area. Another technique which is there in text mining, or I can say NLP, is named entity recognition. Now, NER in short, it identifies and classifies the named entities in text such as people, organizations, locations, dates, etc. So, given a text, it relates that text to some entity. So, sometimes if there is a feedback about a product, let us say the product is book, but instead of the review on the book, if people are talking about the review of the publication, or maybe review about the not the author but about the quality of the paper in that book, so is that relevant to our analysis if we are dealing with the content of the book? So is the paper quality important, or the publication or the delivery of that book through that platform, is that important? But in the feedback, people are writing every such kind of a thing. So we need to know what is the entity that feedback is referring to. This comes under NER, which is named entity recognition. Again, it's a very powerful technique. Even in sentiment analysis, we should have this technique to identify whether that feedback or a review is related to that subject or not. Because if we are considering all the reviews uh, in our sentiment analysis, then we should know whether that review is related to that subject or not. In that case, we can use named entity recognition. It is a very powerful tool which is used in search engines, knowledge graphs, and information extraction systems. Another important technique of text mining is topic modeling. So, like categorizing the text into certain areas, like whether it's a news article or it's about politics or it's about sports. So, giving a topic to a text that comes under topic modeling. And it has many, many techniques. It's again a very, very established area, and a lot of methods, algorithms are there in this area, which are used for document categorization, content recommendation, and the trend analysis. These are some of the applications of this topic modeling, which is to discover the themes of the text. Then text summarization. Again, generative AI has taken this to a next level, where we can do it for summarizing it, or we can do it for extracting the some important information from that. So there are two different kind of summarizations which are done. Extractive, it identifies and extracts the important sentences from the text because some of the sentences may not be relevant. So it identifies the importance of that and extracts that and makes the summary of it. When we talk about abstractive, like writing an abstract of a research paper, so it summarizes the paraphrases and condenses the original text and creates a smaller version of the text. It does not remove any irrelevant thing. It just condenses the whole text. So there are two kind of summarizations which can be done. I am just telling about the definition of these techniques in a way, or some areas where it can be used. This each of the technique is a very very big area. So when we talk about NLP, all these techniques come into play. Then information extraction, it transforms the unstructured data to structured format. Of course, that's the job of the text analytics, and it is used in business intelligence, data analysis, and knowledge management systems. Text classification, it has certain techniques. Sentiment classification again comes into this. So it categorizes the data, it identifies the spam emails. So you will see that in your email system, a lot of emails are already categorized. So some of them goes into spam, some goes into trash, and some comes to inbox. So this categorization or the classification is done using the text classification. Then sentiment again is a kind of classification which classifies the reviews into three categories: positive, negative, or neutral. Then topic classification, which we talked about topic modeling. So this is again a classification kind of a problem in which each document is classified into different topics. Then new area which has come up now is text generation, which has many areas under it. So language models, we all have been using it, and I'm sure each one of us is using ChatGPT, which is a LLM, which is basically a chatbot built on a LLM. So OpenAI has given GPT model. There are many large language models which are there in practice nowadays, and most of us are in use of that. It is to generate the text. In fact, for making this presentation also, I have used ChatGPT. I am no shy of telling this because I think that's the need of the hour, and we all are using it for making the notes, for making lectures, for making presentations. We all are using the large language models, which is generating the text. Lot of examples given in this presentation I have generated using ChatGPT. Of course, we have to be very intelligent while using it. There are hallucinations in ChatGPT. There are false results. For example, for taking this TF-IDF example, I had to create at least 10 examples in ChatGPT to get the right answer. It was creating some examples which were not showing the relevance of TF-IDF. So I had to run it again and again, giving a proper prompt and changing it multiple times. So that also needs some knowledge about it. But yes, this is the future. All of us are going to be using large language models for a lot of um, um, mining or analysis purpose. Chatbots, like ChatGPT is another chatbot, is an example of a chatbot, which is a conversational AI agent which interacts with the users. Right? ChatGPT interacts with the user. So whatever you write, then you can continue with that conversation. Content creation. So a lot of blogs you will see that they are using these LLMs and generating the text. So it can generate the articles, summaries, and other forms of the text generation. Coming back to sentiment analysis, which is the topic of session 2 in this FDP of day 3. Now, it is about understanding the opinions, which may be categorized into three forms. So it is basically to find the emotional tone of that review or the feedback or the social media trend or the market research. there are many applications of it. We are going to talk about some of the applications. So this is again the similar thing. Now, why this slide is because earlier we used to talk about three types of sentiments, but nowadays there are a lot of applications and research which talks about different levels of sentiments and different types of sentiments. So they talk about anger, joy, fear, surprise, toxicity. I am working on one of the project in which we are talking about toxicity of the cyberbullying. So we know that cyberbullying is toxic. So we are dealing with the level of toxicity in that message which is given on in the cyberbullying. Then people talk about different kind of emotions. So there is a lot which has happened in sentiment analysis. So it is not just three emotions. It has gone beyond that, and there are degrees associated with that. There is subjectivity which is given that whether that sentiment is related to that subject or not. So there are various parameters on which the sentiments are categorized. There are majorly three types of approaches which are used in sentiment analysis. One is called the lexicon based. Lexicon is that word which we can say is a token. It can be two words, it can be three words. So any of that is called the lexicon. And there are approaches based on the lexicon. There are tools which are used for sentiment analysis, like Vader is one of the tool which is very commonly used. There are other tools also like TextBlob, which are all lexicon based tools which are used for the sentiment computation. And when it computes the sentiments, it makes a table of those parameters. So Vader gives us 5 parameters related to sentiment, then TextBlob gives another set of parameters, and so on. Some research has been done using the comparison of these tools also. So for the same data set, we compare the performance of these tools. We compare the performance of POS versus the tool. We compare the performance of TF-IDF versus the tool, and so on. Then we have machine learning techniques. Uh, in my first presentation, I had generally talked about the machine learning technique, which is used for sentiment analysis. We have the deep learning techniques. We have CNN, which are basically which apply the convolutional filters to extract the n-gram features. Then we have RNNs, which are recurrent neural networks. Then we have LSTM. And you know, this GPT is an extension of the deep learning technique. So GPT is a transformer-based technique, and transformer is a deep learning technique. Then we have the gated recurrent units, which is a variant of the LSTM. All these techniques are there to compute the sentiments. Then generative AI is there, in which we have the LLMs. We have LLMs are based on the transformers. So a transformer is a deep learning technique. Then there is a prompt engineering. So those who want to do research and they want to explore a new area, I think generative AI is one of the very niche area where you can explore. Uh, in generative AI, most of the job is already done in the sense that it creates a lot of things for you, which you don't have to work about. But what you need to work about is the prompt engineering. So we need to be writing the correct prompt. There are various ways to write the prompt, like zero shot, few shot, and then there are others also. And then we can fine tune that model. So in generative AI also, a lot of research has been done now from the last 4 5 years. We have large language model, then we have small language models, then we have the RAG, which is sorry, I'm forgetting the full form of that. So, which is basically giving your own input to the LLM instead of asking for the pre-trained model, instead of asking the whole set of data. We give our own data and then we say that work on that data so that that data gets more importance. So that is a RAG technique. So there are many, many techniques which have come up in generative AI for sentiment analysis. Now let us talk about some case studies. Um, I think this I will be going very fast because most of the techniques we are using in real world and we are all witness of that. E-commerce. We know Amazon that how it uses the sentiment analysis. You know, there are and in Amazon there are more than 100 million product reviews every day to optimize the product listing. So they use sentiment analysis to improve the search results. There are 100K product rankings, there are 10K customer services. So Amazon has large data for sentiment analysis, and by the way, you can download that. Amazon provides an API through which you can, Amazon provides you the web scraping facility by which you can download the reviews or these reviews given on an Amazon product, and then you can analyze that using the sentiment analysis. You will find lot of projects on Kaggle which are on Amazon data. So sentiment analysis has helped. It's not just Amazon. There are other e-commerce platforms also like Flipkart and all. They have been using sentiment analysis to understand the customer service issues and improve their responses and also recommendations. Then hospitality industry, you can see all the hospitals, even the hotels, restaurants, they are all using the reviews to build their own brand. They monitor the customer feedback and then they track the brand reputation. So it helps in improving their guest experience, like service quality and amenities. They use sentiment analysis to measure the customer satisfaction with specific hotels or services or restaurants. So all those Zomato, Swiggy, Ola, all those hospitality industry, they are using the reviews to increase their customer experience. Then restaurants, I talked about that McD is one of the example. I think there is no restaurant which does not take the feedback of the customers because they want to understand where they can improve. There are so many social media websites where they take the feedback and they want to find the trends and the areas for improvement, such as menu items, service quality, cleanliness of the store. This helps them to make the decisions about their market campaigns, menu changes, and the improvements in their operations. Then airlines, all airlines. In fact, I don't think there is any service industry which is not taking the feedback or the review of their services. It is very, very important for them to understand, and this helps them to improve their areas like check-in, boarding, in-flight service, and they can see the customer service sentiments, and they can use it for increasing their brand image. Then automotive industry, in fact, I think every industry nowadays can make use of the reviews to have the analysis about the customer satisfaction. Then healthcare. So nowadays, hospitals are like hotels only. They give you facility and you also expect a level of facility from the from the hospitals. Also, there are a lot of experiences of the patients related to the clinical outcomes, related to the labs, related to the services given, right? Related to the medicines which are given. So the insights about the healthcare that improve helps to improve the quality of their services and ensure the patient safety. Then nowadays, education is mostly online, like this FTP is also online, and you're giving feedback of this FTP. So that feedback can be used to understand the requirements of the participants, which can help them to improve the teaching methods or whether it should be online, offline, or the topics which are covered in this FTP. So the course content can be more effective. So all these kind of things can be taken as a review and then analyzed for their sentiments to improve on that. Entertainment. I think all the OTT platforms, Netflix, and Amazon Prime and all, they all are taking the feedback. So they can improve on the entertainment that they are providing to the customers. And um, then there are they can help to have the more playlist or maybe more search queries, more video games, kind of entertainment that is provided. So a lot of things can be done on entertainment platform. Then there are a lot of platforms, but I thought it is a repetition of those things. So this is my last slide. As I promised, I have finished my second session fast. So if there is any question, you can ask. Dr. Gaurav, I am not able to see the full screen. So is there something which can be done?
Just give me a second. Thanks.
Yeah, sure.
Now, I have
Yeah. So I just
stopped the
wanted to
screen
see the
sharing.
chat. Okay.
The participants can directly message you, ma'am. We have given the
Okay.
rights.
Okay. Okay. So I don't see any message, any question.
So I think there are no questions as of now, no doubts.
Okay.
So I think we can wind up the session, ma'am.
Thank you.
Some participants are writing great session, ma'am. So they are sending it to me
Okay.
because the participants
Uh,
have the rights to, either they can message the host or co-host. So they are
okay.
generally, texting directly to host. So uh,
Okay.
they are writing great session.
Thank you.
Indeed, it was a great session, ma'am. And thank you, ma'am, for the, insightful and engaging session on this text
Thank
analytics
you.
and sentimental analysis. Thanks a lot.
You surely take the feedback and then I will find the sentiment of that
Definitely,
feedback.
we will be sharing feedback forms with the participants as well, and
Yeah.
we will be, giving you the responses also. And
My
definitely,
suggestion
this
to every participant is that whenever they are feeling any feedback, not just FDP feedback, any feedback on any platform, please be genuine because your feedback is playing a lot of role in determining the policies of that organization. Now you can see that all that sentiments are based on the feedback, but we are always in a mood to feel the feedback as if it is a burden to us and we feel anything in that. So now please be careful when you feel the feedback of anything.
thanks a lot, ma'am. The sessions have provided a comprehensive understanding of how these advanced techniques can be leveraged to extract valuable insights from vast amounts of unstructured data, text data, basically, which is, increasing rapidly in today's data-driven business environment. And especially in the last, you have presented some case studies as well on Amazon or Zomato, and the participants learn how the sentiment analysis can help the businesses to assess customer satisfaction, identify some uh, emerging trends, and fine tuning marketing strategies with particularly some valuable items. And we truly appreciate the time and effort you put into preparing and delivering such an informative session, ma'am. Thank you
Thank
again
you.
for
Thank you.
sharing your expertise with us. Thanks a lot.
Thank you. Thank you so much. Thank you, every participant.
One participant is writing, can we get access to cases if not copyrighted?
Um, See, there are a lot of Python notebooks given on the Kaggle website. and the data set is also given. So you can pick from there. It's all public domain, and you are allowed to copy that. You can use that, so you can take it from there. Amazon, there are a lot of notebooks given on the Amazon products.
Okay. Dr. Swati Khanna would like to ask some questions. I'm unmuting you, Dr. Swati. Please, you can ask your question. I've given rights to unmute.
Yes, thank you so much. Ma'am, your session was insightful. It was
Okay.
great to listen to you. Ma'am, I have a question from you that if we
Mm-hmm.
take any time series data, for example, we are taking a Sensex, NSE, BSC, or DJIA. For example, these days Trump is the winner. So, and
Mm-hmm.
if you want to check that how the sentiments that are coming from US, are they affecting Indian stock markets or not? Can it be
Mm-hmm.
done through sentiment analysis?
Yes, yes. But
So, ma'am,
nowadays, Twitter is not allowing you. So you have to basically go for Facebook or maybe LinkedIn or Insta. Although Twitter is the most appropriate platform to get the information related to this. But matlab, we are helpless in that case.
so no,
You
ma'am,
can go for
not.
the news websites. Yes, you can go for the news website. Lot of news websites allow you web scraping. So you can go to NDTV and other news platforms, and you can get the sentiments from there. I have done a research on the similar kind of a thing in which we downloaded news related to a topic, and then we saw the sentiment and its effect on the some factors. So you can do
So,
that.
ma'am, how to do that? Like, supposingly, bring some, like, this is something which is written. But if we
Mhm.
have only like daily indices, then also we can apply any sentiment analysis. Like, can we find out the herding behavior in the stock markets using those daily indices?
Yeah. You can do that. You download the news articles of a particular day, and then you see what is the sentiment of that. Then next day you download. You have to download a lot of data. See, whenever we talk about mining, it's not just 100 or 200 or 300 transactions that we are talking about. We should talk in big numbers, something which cannot be done humanly. So suppose it's a 1 year data only about stock market. So there are 365 days only. And suppose you
Hmm.
have computed sentiment for 365 days. So it is only 365 rows, right?
Hmm.
But behind that is the sentiment of many, many documents. So if you download news articles of a single day, there are so many news, there are so many channels. So for each day, you are downloading a lot of data related to
Hmm.
text, which is affecting the indexes of the stock market. So that makes it a mining problem.
Okay.
Although my data has 365 rows, but those sentiment score has been computed using a lot of data. So your text mining is before that table. Before converting the sentiment into numbers, your mining process has been taken place. So you can download those news articles from Facebook or whatever way you want to download, some chat, maybe you can download. And then you compile that, makes it into a score, and then you put it in a table where you have 365 entries.
Hmm.
So
Okay,
that way
ma'am,
you can.
I would connect with you on LinkedIn, and I would like to do a similar research. Please
Okay.
guide me in the same
Yeah, sure.
direction.
Sure.
Okay. So I'll connect with, if you are on LinkedIn, or if you, I'll just ask the team to share your email ID, and I'll get in touch with you for
Sure.
the same.
Yeah. I'm
Okay,
on
ma'am.
LinkedIn now.
Thank you so much.
Thank
Okay.
you.
So we have shared the feedback form link as well as the attendance form link in the chat box as well as in the we have sent it through email also, and we'll be posting it in the WhatsApp group. So do fill both the feedback form of both the sessions as well as the attendance form. Okay. Thank you so much, ma'am, once again.
Thank you. Thank you, Gaurav. And thank you, Mamta, for inviting me in this session.
So stay tuned with us, everyone, and we will be meeting tomorrow for another session.
Our pleasure, ma'am. In fact, I think every participant has gained a lot, and I've been receiving message that it's been very insightful session.
Thank you. Yeah.
Thank you, everyone. Good night. Take care.
Thank you.